So thank you and good afternoon. My talk is about Marimo, and I think this is a new generation of Python notebooks for explorers and engineers. First of all, Marimo. What is Marimo? Unlike traditional notebooks, now Marimo notebooks are pure maintainable Python programs. So you don't store any JSON file or obscure other markup which contains GIFs and the output of the program. It's only a pure Python program, yeah, which is stored. And Marimo then creates an intermediate representation, but we'll more on that later. It's also reproducible. Why is it that topic? We will see with some stats later that a lot of the Jupyter notebooks are not reproducible. And it can also be reused. So the usual things you know from Python programming, like importing other modules or libraries, that it's possible. On top of that, you get 3 outputs. So a reactive notebook with already interactive elements, which are built in for graphical user interface, and your notebook immediately reacts to the input. You have a Python script, so you can execute the Marimo notebook like a normal Python project. And you have also tight integration with the package management, which is built in directly into Marimo notebooks. You can also create an interactive web application, which is then be shareable via HTML and WASM. So Marimo does not depend on Jupyter or IPython like other infrastructure, and it's built entirely from scratch, and it's open source. So why do we need a new kind of notebook? So there's a famous quote, "Software eats the world," from Mark Andreessen in 2011, I think. But meanwhile, I think the world is changing, yeah? And with the rise of AI and all that stuff, we can maybe modify this quote and say data eats the world. And you can also see a number of GitHub repos which have doubled last year. And I think this is pretty impressive. So the number of GitHub repos containing Jupyter notebooks doubled in 2024. However, there are a bit difference between AI or data work or a software engineer and a data scientist. These are different roles and they have different backgrounds. One comes from software engineering and programming environment, the other comes from the data area. And however, the data scientist also needs a good IDE or environment to work in because he evaluates data sets. He tests models and algorithms and transforms them, and he wants to visualize also the results of the algorithms and also have the data tangible at the same time. And the data is often from CVS files or DBs or Panda frames. So it's important that we have an easy integration with those information sources. And Marimo notebook enables this kind of workflow. Yeah, we have, and of course in the AI area, Python and Jupyter are dominant. So we'll see there are other environments and languages like Pluto for Julia or Observable for JavaScript or R. This is where the Jupyter name came from. Yeah, Julia, Python, and R. But as we will see, Python is the key language here. So here's a small example from a reactive notebook, how you can imagine this. This is a computed embedding of the MNIST data set. So these are digits from 1 to 9. And we have applied an embedding algorithm and make a kind of point clouds where we can then analyze the data. And the important thing is that you also, sorry, I need to scroll a bit down. It doesn't work somehow. That you see the data which is associated, yeah, with that thing. I will show you that in a later slide also. A bit about me. I'm Bernhard Merkle. I like hiking, and I work for a company, SICK Sensor Intelligence. So what is SICK? Yeah, a funny name for you in this country, of course. So SIG is a sensor solution provider. So we make light grids, LiDARs, camera systems. And I think you have all been in contact with our application or devices. You didn't just know it. Yeah? For example, the Google Street View 3D feeling is generated on LiDAR data that is measured via SIG sensors. So we don't take the pictures here. You see the two devices here. We don't take the pictures, but the sensors, the gray sensors below the cameras are running around with the Google Street View card. It's just that Google has removed our labels. Yeah, here's the proof. And the other application I want to show you, which has also to do with data analysis more and the usage of Marimo, is when you check in your luggage and go to the airport, we read the 1D barcode, for example, on a self-check terminal, and then behind the scenes it hopefully gets into the right direction, read by a reading tunnel from 6 sides, and there is also AI in the sensors, meanwhile, because we have to identify critical luggage, like your backpack with the stripes. Yeah, this can cause a problem with the transport system, etc. Yeah? So cameras can be trained according to data sets that the airport gives us, or they train it themselves, and then they upload the neural network into the sensor, and we can then detect these things. Yeah, so that's about the application. So it's now more to the Marimo. So Marimo is the next generation Python notebook. It's open source. It's, as I said in the beginning, it's stored as pure Python programs. So it's versionable with Git and is very handy. It's also maintainable, reproducible, and reusable. We have interactive UI elements, and as I said, you can share applications as scripts and also as web pages. It also connects easily to database and catalogs and has AI support. So you can also use Claude models or GitHub Copilot. Meanwhile, to start maybe with a bit vibe coding and then fix the vibe coding and implement the rest yourself. I use vibe coding for boilerplate code mostly. So why do we have notebooks problem? Why do we need Marimo at all? So I think Houston, we have a problem here. If you look at these two studies performed in 2019 and 2011, you see, if you look at the first study, 1 million Jupyter notebooks on GitHub, only a quarter were runnable at all. Yeah, you check out your notebook and it does not run. Yeah, maybe environment is wrong or cells are in the wrong order, etc. Yeah, and from these quarter of notebooks, only 4% were running reproducible. So with the result that was checked in. So I think if AI and data is that valuable and that important, we should more care about running Jupyter notebooks. Yeah. Second study of JetBrains, a year later, 10 million of new Jupyter notebooks. About a third have invalid execution history, so it's not getting better. Yeah. And but two interesting numbers I have here. 95% are in Python. Yeah, I said Python is the market. R and Julia are not really playing a role here. And also one interesting fact is that most of the notebooks are quite small, so they have less than 500 lines of code. So if we write an infrastructure for handling these notebooks, we don't need a monster parser or great framework. Yeah, it just have to serve, I think, smaller Python programs. Yeah, and that's what Marimo is doing very well. Yeah. Of course, you have these memes about reproducibility, and I do not want. I find Jupyter notebooks quite useful, but I think, yeah, here's one classical example that everybody has, I think, run in. Yeah, it's a kind of inconsistency in the program because you have changed the first or the sixth cell meanwhile and did not run the last cell, so it's not updated, yeah? Or you have no maintainability between, yeah? Utility functions, etc. You make copies of these notebooks, and yeah, it's not really reusable, yeah. And one principle of software engineering is also reusability. And you know, I think everybody who has worked with Jupyter notebooks knows these diff problems, because the output is also included in the file, yeah, and then you get large diffs which you cannot really handle. I mean, there are workarounds for this. I also used some of them. You can, for example, just strip out, yeah, the output, strip it out. This is a pre-commit hook that you can deploy in your thing, in your environment, or you use some of the Jupyter extensions like Notebook Dime or Jupyter Lab Git extension. But I mean, these are, I call this workarounds. The main problem remains. Yeah, you have the output is still there, so everybody has to stick to these rules, and it's also only a pre-commit hook, so everybody has to deploy it in his environment. Even if you go on the server, like with the Jupyter GitLab extensions, there are problems which are larger diffs, which are then cannot be handled. So Marimo fixed this notebook shortcomings. So here's a demo where I have 3 cells, and you see immediately after I updated the cell here, the last cell with X, the output value of the second cell is updated, yeah? And also of the first cell, yeah. So they are, of course, they are kind of out of order, but I do not have to run the cells referencing my X value. Yeah, it's done automatically, and that is done with intermediate representation with a graph that is built behind the scenes. Of course, if you have a large notebook, which is expensive, yeah, where there are expensive things to computate, you can also turn off this auto update and can run it only on demand. So it's really scalable. It's also possible to cache values in memory or on disk. So there are extensions that you can employ because, for example, if I compute this embedding, yeah, that takes some time on my machine, and I do not want to lose the output. But it's not in a version control, it's just in a cache directory somewhere on my machine. The editing is similar to usual Jupyter notebook. So you create cells, and in the cell can be Python, pure Python code, or Markdown. In the reactive notebook, you also have no hidden state. Here's an example where I reference X in a cell, and then I delete some cell where X is defined and initialized, and if I delete it, I immediately get an error that X is not defined, so my program stays clean, and I do not have to run all Jupyter node cells to be sure that the notebook is in a consistent state. Here you see here also the buttons below where I can insert new cells in Python, Markdown, and SQL, and generate even with an AI prompt. Here I show the example with the UI reactive notebook. So I've created a slider. There's a UI library in Marimo. As you can see, I imported Marimo, and there's a UI package which contains, I think, all of the controls you need with a nice API, easy to learn. Even if you have controls that are not there, you can extend the framework. There are examples in the documentation. And you see here, I update or I change the slider, and immediately my Euler number gets updated because it's computed on the fly. Yeah. So quite handy. You have also interactive data frames. So if you get back a data frame from an analysis or from a SQL query, you have UI controls which enable searching, sorting, narrowing the result set, and you don't have to program this yourself. So this is quite a good stuff. You also can directly query data sources with SQL, for example. There's a SQL parser directly implemented in the framework, and this is quite useful. So let's have a look how this intermediate representation is done. This is done as a data flow graph. So Python cells compose, or Python, a Marimo program is composed of blocks of Python code, and this Python code is also always in such a cell. Here we have such cells here, A equals 0 and B equals 8 plus 1. Then we create a data flow graph which wires together cells and other cells based on variables. So here's an example of a data flow graph on the right side. So you see the second cell is referencing a value which is defined in another cell. So we get an edge here, and etc. etc. Yeah? And this is the intermediate representation. And if I see what runtime and Marimo sees that I change A, it updates all the dependent cells automatically. Despite I can deactivate it if it's an expensive computation. Yeah? And from this graph, I can then generate Marimo notebooks, executable Python programs which can run on the command line or web applications. So this comes, of course, not completely for free. So there's a social contract between the Marimo runtime and you as a developer. So there are a few constraints: no variable redefinition across cells and no cycles. Yeah? Because then we cannot create the data graph you saw in the previous slide. But I think this is a very clear social contract. It's easy to remember. You have a small learning curve, and after a few hours you are used to this. And it scales also for notebooks, and we have seen the number, how big notebooks are usually. If you follow this social contract, you get all the things that are listed that are listed here. I won't quote them because of time here. One caveat is here, there is no tracking of runtime mutation. So, for example, if you insert in a list or something like that, that would, of course, require semantic knowledge about what is the function or the method doing, and this is too complicated to implement. It's also not worth the effort, and it's also not easy implementable. So Marimo does not track runtime mutations. Yeah. The static approach is only the analysis approach is only static. Yeah. However, what comes for free is tracking of package dependencies and versioning. So you see here, I can start a Marimo editor with a ---- sandbox, and then it runs in an isolated virtual environment. Yeah, and the dependencies are also tracked automatically. So each package I import is tracked in the notebook directly via the inline script meta data following the corresponding PEP process. So Marimo started about 2 years ago. It was a small group, I think, at Stanford University. But if you look at GitHub stars, it's already overtaking Jupyter Notebook on GitHub. Yeah, if you give some semantic to that number of GitHub stars. Yeah, but I think have a look at it. The entry, the learning curve is very flat, yeah, you get up very easy, so you don't have to invest a lot of time. Yeah, different people can use Marimo. I think we talked briefly about different roles that came up with AI and data science and machine learning, and yeah, even you see here my presentation here is interactive, so it's not a PowerPoint presentation, but it's a Marimo notebook, yeah, where I run this code in the background, yeah. And it's also uploaded on GitHub. Let's continue. So this is just for reference how you can run it on command line. You can also write test cases on command line. Marimo code generator makes a mapping from your cells to the Python code, and it's pure Python code that you version. This is an example of a web application which is running SQL embedding, yeah. And I think the Marimo got its inspiration also of other notebook environments. So here's Pluto and Observable, for example. And if you check the Pluto homepage, they have the same aspects listed as Marimo has. Yeah, just that it's another language. So of course, in the background, we have this data flow analysis graph. This also we talked about this, and you have also a few constraints that we talked about. So no cycles, no variable redefinition across cells, and no deleting. And you can also follow a few conventions. For example, you can create local variables in cells. Then you start them with underscores, and then they are local to that cell. Okay, and then Marimo, of course, has a parser, which then creates this AST, and data flow graph. And in the data flow graph, you have to do some static analysis like scope resolution and constraint checking, etc. But you can look at it. I mean, it's open source. The implementation is even written in pure Python, so the AST and the static analysis is not done in Rust or any other languages. It's fast enough to use Python internal frameworks. Yes, and we saw usually also the notebooks are not that large. So in summary, I think Marimo embraces some of the Python 10 values. Yeah, simple is better than complex, etc. You have a few constraints that you have to obey, and then you get a lot of things back. The package is designed for extensibility. It comes with batteries, with the UI elements, for example. And yeah, errors should never pass silently, so it's a culture of correctness, and it imposes kind of maybe functional programming style even in notebooks, yeah, which is good. Okay. Check out the homepage of Marimo. There are a lot of examples there. For example, this embedding stuff is coming from there. Here are the sources. They are also quite, the sources for my talk, they are also quite active on YouTube channel. Vincent, for example, he creates a lot of short videos about new features, and in the meantime they have even a cloud environment where you can run Marimo notebooks. So you don't have to install it locally. You can just as Jupyter Lab, you have MoLab, I think it's called, and then you can start directly in the cloud. Okay, that's it from my side. I hope you got some new interesting information, and I would take questions, one or two, if there's still time. Thank you.
Sadly, we don't have time for questions. Hopefully you can catch Bernhard outside or in the hallway track. Next talk is from Elisa to GPT.